Lesson 34, Science 7. And wow, this family is really growing. Today, we're going to simulate reproduction and create offspring number 3 for our mom and our dad. I want you to pay close attention to how this offspring inherits his or her traits, because that's going to help us answer our driving question. How can some siblings look so alike and others look so different? So get your materials from yesterday. Come on, there's no time to waste. Let's start by creating the karyotypes for mom and dad. Look at the screen for how to do this. Make sure when you're pairing them up, leave a little space in between the chromosome pairs. It makes it easy when we're creating the reproductive cells later on. Go ahead, do this now. All right, it's time to turn over all the chromosomes. You know why. Come on, tell me. That's right, because parents don't get to choose which chromosomes to pass on. We want this simulation to be true to this idea about inheritance. So go ahead and turn over all of your chromosomes. All right, you're ready to create a brand new egg cell. I think you remember how to do this. If you do remember, pause the screencast and get going right now. If you don't, here's a little refresher.
You're now ready to create mom's egg cell. This is her reproductive cell that will pass 23 of her chromosomes on to her offspring. Now this process is random, so what I need you to do is randomly select one chromosome from each pair. Just like this. Randomly select one chromosome from every pairing. What we're doing right now is we're creating.
Okay, so you get the gist. Go ahead, do this now. Once you have your egg cell, paperclip those chromosomes and put the unused ones in the plastic bag. Now, let's use the same process of meiosis to create a sperm cell. If you remember how to do this, get right to it. But if you need a little refresher, here it is.
We're now ready to do the same process and create dad's sperm cell. Dad's sperm cell is his reproductive cell that only carries half of his genetic material. So again, randomly choose one chromosome from each pair. Make sure that this process is random and that you're getting one from each pair. Again, these reproductive cells, or the sperm cells, are made in dad's body, in his testes, and only.
Okay, you have the gist. Go ahead, do this now. All right, take a paperclip and put it around the 23 chromosomes that are in dad's sperm cell. Any unused ones go in the bag. It's now time to unite the egg and the sperm. Come on, it's time to simulate what you're seeing right here, fertilization. Unite the egg and the sperm cell to create the karyotype for offspring number 3. Look at the screen as a refresher. All you need to do is pair up chromosome 1s, pair up chromosome 2s, the number 3s, the number 4s, and so on, all the way down the line until you pair up all the way to 23. And remember that pair 23 is special. XX is a female, XY, it's a guy. Pause the screencast now and do this slowly and carefully. Record all the gene combinations, the genotypes on your journal slip, and make sure you record the phenotypes. I can't wait to see what this offspring looks like. Now, use your Visual Profiles reference sheet to help you draw the facial appearance of this third child. Make sure to draw the third child accurately using the data you just collected. Do this now. All right, you know what to do. Submit your journal slip so that I can see your data table and the drawing of offspring number 3. Until tomorrow, keep thinking, keep learning, and get ready because we're constructing an explanation to our driving question.